Alright guys, so we're going to talk about quadratic translations. We've been talking about quadratics, we've been looking at parabolas, talking about the vertex, different characteristics, identifying the points along the parabolas with functions. And what we're going to look at here is translations. And a translation, if you think back to your geometry terms and vocabulary, is basically how a shape, in this case it's going to be a parabola, is moved or manipulated, or how it maybe changes positions on the graph. In this case, we kind of have the central parabola here. We're going to talk about it. It's right there at 0, 0. And it's been translated in my real quick example here. We could kind of change the position of it, maybe even reflect it by turning it around. And we're going to talk about how we do that and how we can identify some things with that. So let's start at the beginning then with this parabola at 0, 0. And basically you can write that down. Our basic setup and our starting point for a parabola before a translation is going to be at 0, 0. And the parabola we have here, I'm just kind of tracing it in. You have it on your paper too, is right there at 0, 0. And the basic function for this is x, f of x, I should say, if we want to do a function, is f of x equals x squared. So this is basically the starting point before we do any translating of the function. And on the parabola, this is where we start. Well, this is called the parent function. So I know you have this little kind of this little fill in the blank spot here. So what this really stands for is the parent function. So the parent function is where you start right before we do our translations. It's at 0, 0. It's f of x equals x squared. Another way to put that could be y equals x squared. If we were putting it in an equation instead of a function, we could have it like that. So let's look at this translation. Let's see kind of what this starts to look like. The best way to do this is to write this vertex form down. You have this on your paper, and you're going to jot it down a couple more times. Hopefully you get familiar with it. But remember, we started with the f of x equals x squared, or the same thing, the y equals x squared. That is basically the parent function, the starting point. But if we want to translate this into vertex form, we're going to use this. This is what you're going to see. This is vertex form for translations. And what that allows to happen is that parabola can start kind of moving on the grid. So it could kind of look like something like this if you look at the examples at the bottom. So if we started with this example right here, this is our central parent function right over there, we could manipulate it using the vertex. We'll see some examples here in just a second. Using the vertex form, you could kind of change this around and translate the parabola into the other parabola examples that you see. Okay, well, how do we do that, and what does all this stuff mean right over here? All right, well, let's start filling some stuff out. Okay, so you have this on your paper. This is your vertex form, and let's figure out what all this stands for. We've got the y equals. Let's start with that A in blue. All right, so the A in blue is giving us some specific information. Let me get us a better arrow in here. So the A is telling us real quick, once this parabola transforms, it's going to tell us a couple things. If the A basically, so if the value for the A is greater than 1, so write this in, if the value is greater than 1, the parabola is going to stretch and become more narrow. Okay, so it'll translate by stretching and becoming more narrow. Make sure you have that down. However, if the parabola is in between, we're going to put 0 is greater than A is less than A is less than 1, and I think I can write that slightly nicer. I apologize. Less than A is less than 1. So if A, the value of A is in between 0 and 1, then it's going to be a compression, which basically means your parabola is going to become wider. Okay, I can even write that right over here. It would become more wide. Okay, when you have if it's in between 0 and 1. Finally, if the reflection, I apologize, if the value for a is negative. Okay, so if you get, switch over here, a negative value for a, wherever a is, then what's going to happen is you're going to get a reflection. A reflection across the x-axis means your parabola is going to flip over and do something like this. You're going to get a parabola that looks like that, or I'll back up maybe like that. That's a kind of a messy parabola, but basically it's going to flip over and it'll start going in a downward direction. Okay, so that's what the A stuff stands for, or the A stands for in our vertex form here. All right, so now let's look at the H. So the next is going to be what this H is. Okay, we're not going to worry about the X and the square. We're just going to go to the H. The H is giving us some information about the X-axis. Okay, so it's telling us, look, the parabola is either going to move to the left or to the right. Okay, and here's how this works. Write this down, and some practice will kind of bring this home. All right. So basically, if the value in the H is, it will move left. Let me put it this way. It's going to move left whenever the value in the X is positive. And I know that seems a little backwards, but just trust me on this. It's going to move left if it's positive. I'll show you this. And it'll move to the right if the value for the H is negative, okay? And I'll show you some examples of that in a second, but you basically want to have this down so you remember that, all right? So if the value, like in this case, if it's a negative right over here, that's going to move, it'll flip around, and basically what's going to happen, that's going to move to the right when the parabola would move to the right, okay? All right, now let's look at the K value. The K over here, let me shift over here. Yeah, the K is going to tell you if your parabola translates up or down, how it moves on the y-axis, okay? So basically what we're saying here is, on this one, it's the opposite. You move left if the K is a negative value, and you move right if the K is a positive value. So we're going to have to remember that, okay? Because you kind of flip it around for your H and your K, all right? All right, so I'll show you some examples on why this works out real quick. But if it's positive on the K, you move right. If it's negative, you move left. It's the opposite with your H value, okay? So let's look at this example. Sorry, that went away for a second. Let's look at this example and let's try this out, and let's kind of bring this all together. I know there's been a lot of kind of writing and talking, but let's look at this. Here we go. We have basically a vertical form, a vertex form right over here, and let's talk about how this would change and how this affects our translation here, okay? Well, let's start with the A, all right? So if we bring the A out over here, is the A a positive or a negative? Well, the A is positive. That's a positive 4. So what that means is, if you go back and look at your notes, anytime you have a positive value where the A is, it's a positive 4, that's going to be a vertical stretch, or it's going to be narrow. So I'm just going to put vertical stretch, or more narrow. That's what's going to happen to our parabola here, become more narrow. And then if we look at the rest of our information, we don't worry about the x or the squared, but that 4, the 4 is where our h was. Well, the 4 has a positive value. So if we look at our notes on that positive value, what that means is this. This is why it flips around. X plus 4, you find the value for the inside of the parentheses by setting it equal to 0. So if I do x plus 4 equals 0, and we do what we usually do with our variable equations and kind of x this thing out, you will get x is negative 4, and that's why it flips around, and that's why it moves to the left, okay? That's why we have the opposite situation here. So what's going to happen with our parabola here? Well, our parabola is going to move 4 places to the left here. So it's going to translate, and I'll write this down in purple here, it's going to translate 4 places to the left. Translate. This pen is not working. Translate 4 places to the left. 4 units left. all right? And then finally, let's look at the -6 right over here, all right? The -6 is the k value, and it is a negative here, all right? We don't have to do a lot of math. It's negative. This is like our y value, okay? This is like our y value here, and basically we're saying it's negative. It's going to go down 6 units. So this is going to translate down 6 units, down 6 units, okay? So we got that down. Let's try another example, because as we start moving on this gets done a lot faster, okay? So we've got that. Let's look at this one. Do a fraction in here. Y equals a -1/2. We've got x minus 2 squared plus 4. How is our graph, how is it going to change a little bit here? And maybe on this one I'll even kind of throw in a quick little graph and kind of show y'all in messy terms how this thing is translated, okay? Because remember, we're starting with something that looks like that. So let's go to our info here. Look at our a value. It's negative, okay? So it's negative. What does that mean is going to happen? Okay, it's negative. It's going to actually be a reflection, okay? So we're going to get a reflection across anytime you have a negative across. So it's going to flip around, basically, is what's going to happen. It's going to be going down, so I'm going to put that down. So we're going to have a reflection. So we're going to have a reflection across as it goes down, a negative, obviously. And then when we look at our h value here, it's a negative. Remember, we flip it now. So that's going to go up 2 units. So this one's going to translate up, or to the right, I apologize. So it's going to go right 2 units. So right 2 units. And then finally, I'll go in green, our k value hanging out over here is a +4. It's positive. We just take it as it is. So it's going to go up. This is our y. Remember, like our y-axis right over here. Remember, this is like kind of our, definitely not kind of, but that's our x. It's going to go up 4 units here, okay? So basically, what we'll look at is we're going, if we look at this, it's going to the right 2 units, and it's going up 2 units. So to the right 2 units, basically, if I went 1, 2 up, and then up 4, 1, 2, 3, 4, basically if I went to the right and 2, that would be my new vertex, would be around here. And then remember, this thing it's a reflection, so it's going to flip over basically, and we're going to end up with something, this is not perfectly scientific, but end up with something that looks like that when we get a translation on this, okay? In word problem terms, and in a short one, I want to show you one last example of this, because it looks tricky at the beginning, but it's actually, it's not once we kind of put it together. This says graph, the graph of f of x was transformed to create the graph of g of x equals x minus 6. Describe the transformation. So basically, they're just giving you some basic info at the beginning, but they're saying, hey, this is your transformation. Describe it now. How is it translating? Okay. Well, remember our form, the g of x right over there. I shouldn't scratch that out, but in black, the g of x is the same as the y equals right over there. We can treat it exactly the same. And remember, we have our a. Okay. Inside the parentheses is going to be this red value here, x minus 6, okay, x minus 6, all right, remember we do it squared, and then at the end, we would just have a plus k, which you're only getting part of the information in this right over here, which is good because we don't need it all, okay, so basically, we're just getting this little section right under here, I'm kind of bring it in, that is that. And basically, we're just describe the translation from here. Well, what's happening? Is anything happening with the A? No, nothing's really happening with the A right over there. We don't have any information. What's happening right over here with the x minus 6? Well, we do the opposite of that. So it's going to the right, all right? So this is going to translate to the right. translate 6 units to the right. And then, do we have any information for the k? No, we don't, so we don't have to put information. So the only thing we can really say here is that this will just translate 6 units to the right. That'd be the only answer there, okay? So if you see a short one, don't freak out. Just kind of place it in where you would have your vertex form, and you can answer how this thing would be translating, okay? So that kind of wraps it up, quadratic translations. Hope that gives you some good information on that, and do some of those practice questions, and we'll see how it goes. Thanks, guys.